Welcome back to this quiz. Right, so hopefully you've got a scrap piece of paper or you have your lab book to work in. I'll go through all the questions and pause the video as you need more time. It's not meant to be a race. Make sure you use as much time as you can to answer the questions and we'll go over the answers. Let's go. Question 1. I've got a velocity time graph here. What's the average speed of the object shown in this velocity time graph? So you can pause the video if you want some more time on that one. I'm going to move on to the second question. The same velocity time graph as before. What distance does the object in this graph cover? What distance does the object in this graph cover? This is certainly one that you'll probably want to work through on a bit of paper. So pause if you need to. I'm going to go on to the next question. Question 3. Out of these three equations, which is not an equation that you've seen for uniform acceleration? Which is not an equation you've seen for uniform acceleration? Well, I'll let you pause there if you need to. But we'll go on to question 4. Question 4 is I want you to rearrange to make t the subject of this equation. And try and do it without a formula triangle. Try and do it without a formula triangle. So pause because you'll need time to work through that one. And let's go through the answers. The average speed shown in this velocity time graph, well, it starts off at 0 meters a second and it speeds up, it accelerates uniformly 1 meter a second every second. So after a second, it's at 1 meter a second. After 2 seconds, it's 2 meters a second. And it gets to 6 meters a second. It starts off at 0, it ends up at 6. The average is just halfway. Okay, what's its average speed? It goes for 6 seconds. Half of 6 is 3. What speed is it doing at 3? It's doing 3 meters a second. So that's where we get this answer. And we've got the points laid out here. The second one is what distance does the object in the graph cover? There's two ways of doing this. The first way is the area under the graph. So this is a shape of a triangle. And if I was to work out the area of this triangle, it's half times base times height, which is equal to half. The base is 6 seconds and the height is 6 meters a second. That equals 18, and the units, that's seconds, and that seconds cancels out, 18 meters. That's way number one. The second way is a bit of a tricky way, is for something that's accelerating, you can just look at its average speed, which you worked out in the first question. The average speed, even though it goes from 0 to 6, the average speed is 3 meters a second. And what you can do is you can say, well, even though it's speeding up, its average speed is 3 meters a second. If I take that, if I do distance equals velocity average times time, if he was just going at that average speed for the 6 seconds, that also equals the 18 meters. So that's two different ways to do that, both the same answer. Which of these is not an equation for uniform acceleration? You've seen this one. You've seen this one occasionally from rearranging, but you'll see it a lot more often from today's lesson. And this one I just made up. So even if you didn't get that right, the whole point of this is you're going to become more familiar with these two equations and the third one as well. And rearrange to make t the subject without a formula triangle. So I want to make t by itself. I also want to make t on the top of the fraction. So I'm going to times both sides by t. And then I get vt equals d. Then I'm going to get rid of my v. by dividing it. And that gives me T equals D over V. 3 marks. So mark it, write your mark down in the back of your book, and we'll move on to the next part of the lesson.